Hello students, today I am going to taking the NEET classes. So that is the first chapter is about electric charge and electric field. The first question we are going to understanding when a soap bubble is charged. A option, it contracts. B, it expands. It does not undergo any change. D, it bursts. So see here. When a soap bubble is charged, this is one soap bubble. So when it charged, it may be positive or it may be negative charge. Anyone charge it is there. Look at this one. So this is the one soap bubble. So when you charge, for example, either it is positive charge or negative charge. When you charge, then what will be happen? So the same charges are there. They are repel with each other. When it is repelling, there what we are going to see it is going to be expanding. Because of that, what happens now? It expands. So the first answer what we are going to see that is the first one. So that is a B. We are going to see that option B. Okay, option B is the correct answer. So second one, an electric charge in uniform motion produces an electric field only. B, a magnetic field only. So C, both electric and magnetic field. D, neither electric nor magnetic field. When charge it is in the motion, so then we are going to see that both electric and magnetic field we are going to get it. Both. So when it is in the uniform, so that time also we can see that electric field and magnetic field we are going to see that. Electric and magnetic field both are perpendicular with one another, but we are not going to see that electromagnetic radiation. To get the electromagnetic radiations, this charge must be what? Accelerating. Accelerating is non-uniform. That should be what? Non-uniform. So here uniform motion means we are getting the both electric and magnetic field we are getting it. So that is a C option. It is about the water. C, we can see that C. I am going to reading the water. Third question. That third question is there are two charges plus 1 microcoulomb and minus 5 microcoulomb. So the ratio of the force acting them. So acting them will be. So here we are going to see that. What will be happen the charge plus 1 microcoulomb to the minus 5 microcoulomb or minus 5 to the plus 1. So that is Q1 and Q2 we are going to see that. According to the Coulomb's law, it says that the force is directly proportional to the product of their charges, product of their magnitude of the charges. Okay, so then and another things according to Newton's this one third law, every action there is equal and opposite reaction. So that's why here F12 vector equal to F21 vector. So means first charge to second charge or second charge to first charge, it is what a force is acting, it is the same. So same force is going to be acting. Because of that reason it will be what 1:1 we can see it. Third option it is a B. Third option it is what B. So next fourth one, an electron is moving around the nucleus of a hydrogen atom in a circular orbit of radius r. The Coulomb force between the two is. See, this is the one electron. This electron it is revolving around to the nucleus. This is the hydrogen atom. So it is revolving. So revolving around to this one. So then we can see that there is a centripetal force and Coulomb force, it is acting same one. But here they have option, it is mentioned like this way. So Ke square by r square. A option it is Ke square by r square into r. So they have not put the any vector. So unit vector also they are not put, just they have written it. So it means that we are thinking that it's a magnitude. Okay, we are thinking it's a magnitude. So B also same thing. It is Ke square minus Ke square by r cube into r. And C Here the option is like this way: k square by r cube into r vector. Okay, so k square by r cube into r vector. So actually what happens, this is correct, but the direction we have to see that. Another one, D option, it is given that minus k square by r cube into r vector. So which is correct? Either C or D. These two are, it is not correct because there is no vector notations are not there, so it is not there. So we are thinking about either it is C or D, which is correct. Now here plus n is there, here minus n is there. So this is electron is negatively charged and nucleus is positively charged. Both are, it is force of attraction will be there. The force of attraction it indicates by the what? Negative sign. It indicates the what? Negative sign. So because of that, the fourth option it is the D. Fourth option what we are going to see, it's a D. Okay, so it's a D. Next, fifth one we are going to see that an electron is moving around the nucleus. Okay, sorry, fifth one. Fourth one it is a D, no? So now fifth one, two particles A and B having equal charges placed at a distance d apart. Okay, a third charged particles placed on the perpendicular at a distance x will experience the maximum Coulomb's force. Will experience the what? Maximum Coulomb force. Options I will write down here. This is the fifth question number. So option it is. So now we are going to see that fifth problem. So two particles A and B having equal charges placed at a distance d apart. A third charged particles placed on the perpendicular at a distance x will experience the maximum Coulomb force. What will be the x value we have to find out. So the option it is given like this way. So this is x equal to d divided by root 2. And B, so that is x equal to b by 2, and C, the option is C, x equal to d divided by 2 root 2. Okay, and D option it is mentioning like this way, x equal to d divided by 3 root 2. Okay, 3 root 2. So here two charges it is given. This is the one, two charges are there. This is Q. The distance between these two are, it is d by 2. At the midpoint means this is the one distance x. Okay. So from here to here the distance what we are going to take now? D by 2. And this one distance d divided by 2 we are taking it. The here one charge it is placed, that is Q charge. This is the one Q charge it is placed. Okay, so the force exerting from this capital Q to small q. So both are it is positive only. So it will be moving in this direction. So this is from the what? F. Okay, here Q is there. The force exerting from here to here is the Q. Okay, similarly from here also we can see that the force is exerting at this point. Okay, so this point we are going to see that. So this is the one F, this one is F. The net, this is F net, we can see that. Okay, F net. These two forces are resolved in two components. One is F sin theta. Okay, so this also F cos theta. So theta is this also theta only. So if the force exerting anyone, we can take that F cos theta. So similarly for this direction also, this is F sin theta. So this also we can see that F cos theta. Okay, so now the hypotenuse, that is from here to here, that hypotenuse x square by d by 2. Okay, so hypotenuse square ಅಂತ ಹೇಳ್ತೇವಲ್ಲ x square by d by 2 whole square, okay, to the power of 1 by 2. 1 by 2. Similarly, that solid also same thing. So F net, the force net equal to, so these two are get cancelled, only we can take the what F cos theta. F cos theta plus F cos theta is 2F cos theta we are getting it. Okay, 2F cos theta. Now we will substitute the force, that is a K capital Q small q divided by x square plus d square d by 2 whole square. Okay, d by 2 whole square, this is to the power of 1. Okay, this is to the power of 1 into, so cos theta means again we can see that adjacent by hypotenuse. Adjacent divided by hypotenuse means this is the word adjacent. This is what we are reading now. Adjacent, that is x divided by this value, x square plus d by 2 whole square to the power of 1 by 2. 1 divided by 2. Now net force we can write on this side. I will write on here, x square plus d by 2 whole square to the power of 1. Okay, so now 2kq small q x divided by, this is x square plus d by 2 whole square to the power of, okay, so this is 3 divided by 2. Why we are taking 1 plus 1 by 2 is 3 by 2. This is F net we are getting. Now to calculate x, according to the statement, it's saying that df net divided by dx is equal to 0. Okay, that will be equal to 0. We have to differentiate this equation. For this differentiating this equation, so this is d by dx bracket, this is a 2kq small q x divided by x square plus d by 2 whole square to the power of 3 by 2 equal to 0. Now to differentiate this one, the first part, upper part and lower part are there. First we are differentiating the upper part, then we are going to differentiating the lower part. See, this one differentiating, so this is 2k capital Q small q divided by x square plus, this is d by 2 whole square to the power of 3 by 2. 3 by 2. So again we have to differentiate lower part. Lower part, if you go up, so that is minus 3 by 2. This part is as it is, 2kq small q. Okay, so divided by, this is x square plus d by 2 whole square. Okay, d by 2 whole square to the power of, so this is a 3 by 2. Again, if it is go minus 1 antandre, so it is nearly, we can see that 5 by 2. Differentiation of this one is 2x. That is the what? 2x. We are going to write this equal to 0. If I shift that side, okay, this 2 get cancelled. Okay, so 2kq small q divided by this is x square plus d by 2 whole square to the power of 3 by 2 equal to, this is 3. Okay, so this one is 2kq divided by x square plus d by 2 whole square to the power of 5 by 2. Okay, into x we can write. This 2kq get cancelled, this also get cancelled. Okay, so both are, it is going to be get cancelled. So then cross multiplied here, when you cross multiply okay, when you cross multiply, we are getting the options here. When you cross multiply, so this is x square plus d square by 4. Okay, so this is 5 by 2, this is minus 3 by 2. So LCM it will becomes what? 2. So 5 minus 3 is 2 by 2 is 1. 1 equal to 3 into x, 3x. Okay, so 3x square, because here another one x is there, no, that is x, this x. So that gives what? X square. So we are sending this side, so then d square by 4 equal to, this is 3x square minus this is x square. So therefore 2x square equal to d square by 4. So or x square equal to d square by 2 into 4 is 8. X equal to, so square root if you are taken, then square root of 8 it will be written like 2 root 3. So option it is about the water x equal to C option. Option it is the water C. Option and the C. So those who are expert in differentiation, just don't write down this one. So this step necessary illa. So write down this directly and differentiate. So you will get the what? This type of one answer we are getting. Here this just for your understanding I have done. So cancel and then this will go. So directly you get this and this 2 or 3 steps you skip, means directly you will get the what? Answer also. ಇಲ್ಲಿ ಏನಾದರೂ ಸ್ವಲ್ಪ ನೀವು ಮ್ಯಾಥಮೆಟಿಕ್ಸ್ ನಲ್ಲಿ ಪರ್ಫೆಕ್ಟ್ ಇದ್ರಿ ಅಂತಂದ್ರೆ ಸ್ವಲ್ಪ ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡಿದ್ರೆ ಅಂತಂದ್ರೆ ಯು ವಿಲ್ ಗೆಟ್ ದ ಆನ್ಸರ್. ಈಗ ನಾನು ಅದು ಶಾರ್ಟ್ ಮಾಡಿದೆ ಅಂತಂದ್ರೆ ಯು ಕಾಂಟ್ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಎನಿಥಿಂಗ್. ಅದಕ್ಕೆ ನಾನು ಏನಾದರೂ ಸ್ವಲ್ಪ ಎಲಾಬ್ರೇಟ್ ಮಾಡಿದ್ದೀನಿ. ಸೊ ಯು ಮಸ್ಟ್ ಹ್ಯಾವ್ ಟು ಬಿ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್. ಓಕೆ, ನೆಕ್ಸ್ಟ್ ಕ್ವಶನ್. Next, sixth one. If a charge q is placed at the center of the line joining the two equal like charges q, the system of the three will be in equilibrium if q is. ಇಲ್ಲಿ ಏನದ sixth ಏನದ ಅಂತಂದ್ರೆ, if a charge q is placed at the center of the line joining the two equal like charges. Okay, so two equal like charges. I hope you understood now this one. So next we can solve it. So first option what we are reading of B. This is second one is C. Third one is B. Fourth one is it is D. Fifth one is C. Now sixth problem we are solving the what? Sixth one. Sixth problem. Okay. Sixth problem. So according to this, if a charge q is placed at the center of the line joining the two equal charges like q, the system of three will be in equilibrium. So now look into this one. This is the one. There are two capital Q's are there. At the center small q if it is placed. Okay, at the center small q if it is placed. So then the three equilibrium will be. So equilibrium state is what? So the total distance we can see that d by 2. This is d. The total distance is d, and from capital Q to small q the distance is d by 2, and this also d by 2. Net force on Q equal to 0. Okay, net force on Q equal to 0 antandre. So the one force is from this side q to small q, again another one force is this q to the small q. The total we are getting the water net force is equal to 0 we are getting it. So then we can write on one, it is k, on the force once again. So this is one force, it is the two charges are there, no, that is the one net force, that is a K into Q square, okay, divided by D square, plus another one K into small q into Q. So that is a KQ small q divided by D by 2 whole square. D by 2 whole square we are in. Yeah. So this we can write down equal to 0. Okay, equal to 0. So this is KQ square by D square equal to minus KQ divided by, this is D square divided by 4. This Q get cancelled. This is D square by 4 get cancelled. K also get cancelled. The remaining what we are getting, you know, so small q we want to calculate the small q, this is q equal to minus 4q, therefore q equal to minus q divided by 4, minus q divided by 4. Option it is given that the option it's about what, D, that is B option. Seventh, it is that 3 charges plus 4q comma capital Q and small q are placed in a straight line of length L at a point distance 0 comma L by 2 and L respectively. So what should be the value of Q in order to make the net force on Q to be 0? Okay, so this we are going to calculating. So first we are going to understanding the what the similar type. This is the what net force acting on Q is equal to 0. Sixth, how we did know the same type it is also. Just I am going to draw the diagrams and then you are going to understand it. Now question number 7 we are going to discussing. So this is the 7th one. Charge, this is a 4q and here is the q, it will be there. So this is the one capital Q it is given. Okay, so if a charge q is plus 4q and q are placed in a straight line of length L, the straight line of length it is how much, it is L, the straight line of length is L. Okay, so L at a point 0 comma L by 2 and L respectively. What should be the value of Q in order to make the net force on Q to be 0? Okay, Q to be 0. So that force we are going to see that. So this is from here to here, the distance what we are going to take the L by on Q. Small q we can see that force on Q equal to, so the force exerting between the two charges, that is one force is Q equal to capital Q into small q. Okay, capital Q into small q divided by the distance from here to here, it is the L by 2 whole square. Another one we can see that plus 4 in K into this and this charge we can take it, 4q into Q divided by L square equal to 0. L square equal to 0. So now see, this will go up, that is L square. So that is a 4kq divided by L square. This is minus. Okay, that side it will be going. So that is 4 minus 4k. Okay, q into q. Why I am writing q into q means because here we are going to get the, it will become what, q square. So this 4k get cancelled on q, 1q get cancelled, L square and L square get cancelled. So therefore q equal to what we are getting now, minus q. Okay, q equal to what we are getting now, minus q. So the option for this one is A. A option is correct. Option A it is the correct. Okay, option A it is the correct. So now next question it is understanding the what, 8th. An infinite number of charges, each magnitude q, are placed along x-axis at a distance x equal to 1 meter, comma 2 meter, comma 4 meter, and 8 meter and 16 meter, and so on. But the consecutive charges are of opposite sign starting with the plus q at x equal to 1 meter, and a point charge q naught kept at the origin experiences a force of magnitude. Here we are going to calculating the water infinite number of charges, each magnitude is q. It is placed along x axis at x equal to 1 meter, 2 meter, 8 meter, 16 meter, and so on. Means the charges it is placed like this way. This one charge, so one charge it is placed at the 1 meter, 2 meter, okay, and 4 meter, 8 meter, and 16 meter, like that way. Means so double, so 1 double is 2, 2 double is 4, 4 double is 8, 8 double is 16, 16 double is 32. If you have placed okay, so consecutive charges are opposite signing starting with the plus q at what x equal to 1 meter. So here starting with opposite sign means this is plus q, this is minus q, plus q, minus q, like that. So we are going to placing, okay, opposite sign starting. A point charge q naught is kept at the origin. So there is one charge, it is kept at the origin, okay, at the origin. A point charge q naught at the origin experience a force of magnitude. What will be the force exerting on that q naught, that we are going to calculate. So that is the question number 8. Okay, question number 8 ನಲ್ಲಿ force experienced by that test charge ಎಷ್ಟಿದೆ ಅನ್ನೋದನ್ನ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ರಿ ಅಂತ ಹೇಳಿದಾರೆ ಅವರು. So the force exerting on this one is F equal to, we can write on, so q naught by, so this is 4 pi epsilon, the formula r square. So one is 1 by 1 square minus ಇದು ಪ್ಲಸ್ ಇತ್ತು. ಈಗ ನೆಕ್ಸ್ಟ್ 1 by 2 square alternatively plus 1 by 4 square. Okay, so it will be going to be like this way. It means that q by q naught by 4 pi epsilon naught, this is 1, okay, so minus 1 by 4 plus 1 by 16, so on we are going to write down. So this may going to write down q into q divided by 4 pi epsilon naught. So there is a series, it will be there, that binomial series we can take it. So then we are going to write down that equation, we may going to write down 1 divided by 1 minus of 1 by 4. 1 minus 1 by 4. We are going to write down this equation. So you know 4 ಆಗುತ್ತೆ, 4 plus 1 5, 5 by 4, 4 get cancelled. So then q divided by q naught 4 pi epsilon naught, it is 4 divided by 5. This 4 get cancelled. Answer what we are getting now, q by q naught, 5 pi epsilon naught. This is F. Force experienced by that charge is how much? So that is the 8th, its answer is B. Okay, 8th answer ಏನಾಗ್ತದೆ B ಅದ ನೋಡಿ. ಈಗ ನನಗೆ ಶಾರ್ಟ್ಕಟ್ ನಲ್ಲಿ ಅಂತಂದ್ರೆ, so directly you can start with this one. You know the series, binomial series, one theorem it will be there. So using that cross multiplied, you'll get the answer only. Okay, within 2 minutes you'll get the answer.